So I'd like today to sort of focus on looking at some of these conversions that involve stoichiometry coefficients, and those sort of come into play when working with questions like this. Usually, we're formerly used to just working with one-step conversion factors. In other words, it only takes us one step or one conversion to get to a final answer. But you'll find, especially in stoichiometry reactions, you actually have to employ intermediate conversions in order to work ultimately to a final answer. There's a lot of steps that you have to take sort of in between, and sort of make conversions in between in order to get a particular outcome. And the idea to remember, sort of the idea to catch on to, is that there's sort of a trend, and there's sort of a pattern that is followed. And once you do that pattern enough, it actually becomes intuitive. So in this example here, it says how many grams of hydrogen fluoride, right? This is HF, are produced from the reaction shown below if 5 grams of H2 is used. So really, when looking at a question like this, first and foremost, we want to understand what's being asked and what's being given. That's sort of an indispensable part of chemistry, and perhaps of many modes of studies. You know, we always work with what we're given, and then we work our way upwards. And so what we're given here is, 5 grams of what seems to be hydrogen gas. If it were just hydrogen, then we're just talking about a particular element. But since there's a sort of a subscript of 2, that implies we're working with 2 hydrogen atoms making it a gas. So it's hydrogen gas. So it's asking us from the reaction shown below, which is this reaction here, if 5 grams of hydrogen or hydrogen gas is used, how many grams of hydrogen fluoride are produced? Now, the thing about these questions is sort of to recognize the order in which they're said. Usually the order is, okay, if you have 5 grams of hydrogen, how many grams of hydrogen fluoride, right? They always start, I mean, usually in conversation, you always start with what you're given. When sort of describing one of these problems, you say, okay, well, if you had 10 cups, how much Coke could you pour, right? But you never say, okay, you have a sort of a mysterious amount of cups, or you have a mysterious amount of Coke. How many cups would you need? That's sort of a cryptic way of describing the situation or asking the question, and that is the very style of sort of how these questions are presented, um, or through the means through which these questions are presented. So it's sort of reversed, but recognizing it goes a long way. So how many grams of HF are produced? And so we're given this. You always want to start with what you're given, right? You're given 5.0 grams, and you want to label it as well. That's hydrogen gas, right? So that's H2. And the idea is to string along enough conversion factors this way, in order to eventually get 2 grams of HF. And so the idea, I mean, is that if you convert, 5 grams of H2, if you first convert it to moles, and then convert those moles to HF moles, and then convert those HF moles to grams, that's eventually going to be us moving towards answering the question. So first, let's sort of figure out, sort of the first connection that we want to make, the first ratio, so to speak, is a particular amount of moles of hydrogen gas equated to a particular amount of moles of HF, right? And you can sort of recognize that this relationship is between a reactant and a product, right? It could really be anything. I mean, it could be between a reactant and a reactant, or a reactant and a product. It really doesn't matter. But back to the original case, we're trying to first figure out, okay, how many moles of hydrogen gas, um, uh, or how many moles of in this case, hydrogen gas, since hydrogen gas is what we're given. How many moles of hydrogen gas does it take to make a particular amount of moles of hydrogen fluoride? And so, in order to answer that question, we need to be able to convert this to moles. And so, what you would do in that case, and so this is sort of the universal process of finding how many moles are in a particular amount of grams, is you find what we call the molar mass. And the molar mass, essentially, what it gives you is it gives you, um, like for instance, in this case, if you had hydrogen, hydrogen's atomic mass is 1.008, which means that its molecular and molar mass, which are sort of the same thing but described in different units, the molecular and the molar mass, in this case, the molar mass, is 1.008 grams. In other words, 1.008 grams is equal to 1 mole of hydrogen. But if I were to sort of put this in terms of H2, not just hydrogen, then I need to take into account that there is not only 1.008, but there's 1.008 times 2. And that's essentially your molar mass for hydrogen gas. And why they call it molar mass is precisely because your end amount is in grams per mole, right? So you're actually saying, okay, if you take that much amount of grams, then that will have 1 mole of that thing in it. In other words, it will have 6.02 times 10 to the power 23 of that thing in it, which in this case is hydrogen gas, or before, as we said, was hydrogen. So 1.008 times 2 would be your molar mass, and if you were to do that, in a calculator, you would essentially get two. So you would get 2.016, and that would be your grams per mole. So in 1 mole of, or if you weighed out 2.016 grams, you would have 1 mole of hydrogen gas, and that, of course, you would have to take out 1 mole of hydrogen gas in order for you to have 2.0616 grams of hydrogen gas. So what you would do is you'd essentially use this conversion factor. This is in and of itself a conversion factor. You'd say this is 2.016 grams equals 1 mole, and of course this is in terms of H2. And so you say that, okay, well, how can I use this conversion factor in order to go from 5 grams of hydrogen to how many moles is that? Well, what you do is you sort of just you put this you look at this ratio, and you're looking at this ratio, and you're saying, okay, what do I put on the bottom so that my grams of hydrogen gas cancels out and I'm left with moles? Well, what you would do in that case is you'd put your grams of hydrogen gas on the bottom in the denominator, and in your numerator you would put 1 mole. And that essentially answers our question, because what we were asking was how many moles are in H2, uh, and that is sort of an intermediary step in trying to find out how many moles of H2 do you need to make a particular amount of hydrogen fluoride, HF. And so this answers our first question, because these hydrogens sort of cancel out, and of course the grams do as well. And when you do this multiplication process, which is 5 over 1 divided by 2.016, that is precisely how many moles are in these many grams of hydrogen gas. So this itself gives you moles in terms of hydrogen gas if you had 5 grams of it. But that's sort of an intermediary answer, because if I were to stop here, I essentially would just be left with the amount of moles that consist in 5 grams of hydrogen gas. That's not what I want. What I want eventually is how many grams of HF are produced, right? So I eventually want grams of HF. So, so what I'll do now, and this is what I said before, first let's make a conversion factor that we can work through. Um, I want to express this in terms of grams of HF. But before I can do that, I want to first express it in moles of HF. I have moles of H2, but what do I need to multiply? And this is, of course, moles of H2. What do I need to multiply with? I need some conversion factor here so that my moles of H2 can cancel out. And then I'll sort of be left with, I'll be left with moles of HF, right? So ideally, if I had, an X amount of moles of H2 here and an X amount of moles of HF here, then I could cancel the moles of H2 and then I'd be left with moles of HF, right? And what you want to do for when you're at this stage is really look back at the chemical equation. And if you've balanced your chemical equation, and in some cases you'll have to, but if you balance it, eventually what you can do is you can just make sort of a ratio, a proportion here on the level of the chemical reaction sort of, or equation, if you will. And what that ratio would be is you would look at the three and you say, okay, well, three moles, and that's what stoichiometric coefficients are in terms of. They're in terms of moles. 3 moles of H2 gives you 6 moles of hydrogen fluoride. That itself, you can extract that, and you can say that, okay, well, 3 moles of H2 is equal to 6 moles of hydrogen fluoride, right? So if you want your mole, so you could put that here. You can say, okay, well, you could say 6 moles of hydrogen fluoride, 3 moles of H2, and then effectively your moles of H2 would cancel. And then once you include everything that you had before, of course, but once you finish the process, you have how many moles of HF is would react with 5.0 grams of H2. And that's awesome, right? Because that essentially gives you your answer. Now you have how many moles of HF you would have if you have 5.0 grams of H2. But remember, and this is sort of a reoccurring habit that you want to sort of install in yourself, is you want to go back to the original question. You want to look at the question. You want to say, okay, what is it asking? It's not asking moles of HF. It's asking grams of HF. But is it a problem that your answer is in moles of HF? And no and yes. No, because you're one step closer to finding the answer, but yes, because you don't have the answer yet. So what you do is you're like, okay, I have 6 moles of HF. What can I do so that my moles of HF will cancel? Is there a conversion factor that I know of that can take me from moles of HF to grams of HF? Well, if you remember, the molar mass of a compound, and this is what HF is, it's a compound. The the molar mass of HF is expressed in grams per mole. So if you know how many grams per mole there are in HF, you can say that X amount of HF is equal to Y amount. X amount of HF in grams is equal to Y amount of moles of HF. And then you can put your moles of HF down here, your grams of HF up here, and then you'd cancel out your moles and you'd be left with grams at the other side. So that's essentially what you want to do. You want to find out how many grams, you want to find the molar mass of HF. And the molar mass of HF, so HF, right, if we're talking about molar mass, hydrogen, like we said before, is 1.008, and there's only one atom in H. And then you have your F, so you want to also count the atomic weight, which in this case is the grams per mole for fluorine. And if you were to do that, fluorine is a little heavier. It's 19.908. You could round that to 20. It's 20, so 20 grams per mole if we're talking about molar mass. And so you could put like a little grams per mole here to be more precise. But once you add this up, you would essentially, you wouldn't, well, yeah, right. So once you, let's see here. Let's see. Right. So it's actually not 20. It's actually a little less than that. It's not. It's 18. It's 18, I believe. 18 point. Let's see. 18.9 for the atomic mass. So if you were to add that up, you would eventually get 20, or something relatively close to 20. And so you have then sort of a conversion factor. You have grams equated to moles. You could say that 20 grams, right? 20 grams of HF is equal to 1 mole of HF. And then of course you can sort of put this back here so that your moles of HF would cancel out. 1 mole of HF would cancel out, and then you have 20 grams on top. And then so you can see here, I mean, your moles of HF would cancel, and you'd just be left with grams of HF, and that's essentially what we wanted, right? At the other end of this problem, that's what we wanted, grams of HF. So essentially what you would do is you'd put 5 multiplied by 1 over 2.016, and then you'd multiply that by 6 over 3 and multiply that by 20 over 1, which is just 20, right? And then you get 99.09 grams of HF, and that solves your problem. So it's really not that difficult, right? You're just sort of plugging in conversions along the way. You're stringing them along, and it makes sure it essentially makes sure that your units are all good and they're correct.